Hello again, wonderful students. For this video lesson, we're just going to be working on the covalent bonding review assignment. Keep in mind with any of these assignments, feel free to fast forward to anything that you need help with. These are not meant to be you just follow along and do the assignment. Try the assignment first in this video, so if you get stuck, you can get help in the explanations for it. So let's go ahead and get started. You'll notice that this looks similar to our other covalent assignment just to start us off because it's important that, again, we're reviewing covalent bonding. So looking at these images here, you can see hydrogens here bonded to oxygen, so that's our water, right, H2O. You can see CO2, and these are both telling us that this is covalent. And it's important that we remember the difference between covalent and ionic. So you can see that these are sharing electrons, so you can see these 1, 2, 3, 4 electrons, and they're actually shared. Which is why the image is drawn this way. If you come over to sodium chloride, for some reason that picture is missing, but whatever, we'll just use the MgCl2. And you can see that our electrons are actually transferring over. That's why they're using an arrow. So that's one of the important things to note. So circle one with covalent compounds. And I'm actually just going to add a really quick note here. It's important to know that these share electrons. And that ionic actually transfer electrons, as indicated by the arrow. And that'll make a difference when we draw our Lewis dot structures down here at question number 4. Because that's going to be very different. I shouldn't say very different. It's going to be a little bit different than when we drew ionic Lewis dot structures because there's some differences that you have to recognize. So with that, covalent compounds consist of all in metals or nonmetals. So if we look at our periodic table here, we can just kind of see and we'll observe the elements, hydrogen, oxygen. Please note that metals are going to be the ones highlighted pink and green on our periodic table. So hydrogen is actually not labeled as pink or green because it's a nonmetal. Oxygen is yellow, meaning it is a nonmetal. So with that, covalent compounds consist of all nonmetals. That's an important thing to remember, is that ionic compounds always contain a metal. And that's the easiest way as we move into the next couple days where you'll start having ionic covalent stuff combined. It's important that you can quickly be like, okay, metal, ionic. Charges exist only in, and that's another thing we can see here looking at our assignment. Looking at these examples, we can see that only in the ionic do we label charges. Why? Because charge indicates electrons or protons are winning, quote unquote, winning the battle, right? There's more protons or more electrons. Well, covalent, since they share electrons, they're not gaining or losing electrons. So that doesn't apply. So charges only exist in ionic. And so we're going to say charges exist only in ionic compounds. Which one transfers electrons? Well, we just said that, ionic. Which one share electrons? Covalent. So using your knowledge of electrons, explain why there are no charges in covalent bonding. Well, simply put, because covalent share. Charges come from gaining or losing electrons. For question number 2 down here, use the information below to determine formulas and naming for covalent compounds. Again, this is kind of meant to be inquiry. This is meant for you to learn by seeing examples. So with that, when naming covalent compounds, the prefixes indicate the number of what in the compound. So what we really have to do here is actually start looking at our prefixes. So we see this formula CO, and then it just says carbon monoxide. CO2, carbon dioxide. NO, nitrogen monoxide. Or come over here, dicarbon, again, that prefix, H6 hexahydride. So I think what that's telling us is di, if we look at our periodic table and we actually go to the back of it now, we can see our prefixes here. Oh, di2, and that formula tells us C2. And then it says hexahydride, well, hex is 6, H6. Oh, so it tells us the number of each. And you can say atom, or I would accept, atom or element in each compound. Similar to ionic compounds, the second atom, and we can see it always ends in "ide," 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 "ide." So they still have that IDE ending just like an ionic compound does, but again, it's still only on that second word. So that's going to be an IDE ending. Question number 3, when the first atom is alone, that is no subscript, so we can see here, CO, okay, it's alone, there's no subscript, and we didn't put a prefix on there. NO, it's alone, we didn't put a prefix. CO2, we didn't put a prefix, but if we come to this side, well, when it said C2, we did actually put a prefix on there. N2, we said dinitrogen. So when the first atom is alone, it does not get a prefix. When the second atom is alone, no subscript. So we look at like CO. Well, we actually still put a prefix on there. Mono, NO, mono. So we can put a prefix for one, but only on the first word. And then this is just simply asking us to look at our periodic table and practice some of these prefixes. So the prefix for 2 is di, 4 is tetra, and 5, looking up here, says, we gotta scroll over a little bit more, 5 it says is penta. And then we need to practice actually naming these. So to name things, kind of using these examples up here, we could actually come up with some rules. You're always going to write a prefix, but there's this exception of not doing mono on the first word. So prefix, and maybe I'll say except mono on first. Plus the element, so then you just write the element name. Nope, I threw an extra T in there for some reason. Plus, then you would go back and, looking at these examples here, it looks like you would then do a prefix regardless, because you can put mono, di, hexa, it doesn't matter. So then you're going to do another prefix, plus the element, and then you just have to add that IDE ending on there, so with IDE. So if we practice this, let's try N2O6. Well, so following our rules, we're going to put a prefix. Since it says N2, I'm going to write di, and then it says except mono. Well, we didn't need mono, so plus the element, so dinitrogen, plus the next prefix. Since this was 6, our prefix is going to be hexa. And then following our rules again, it says element with IDE. So this was N2O6, so this is going to be ox, and then with the IDE ending is oxide. If we do this next one, well, since there's one phosphorus, the prefix is mono, but remember, we don't put mono on the first word. Prefix except mono. So therefore, we're just simply going to write out the word phosphorus, and then Br5. So Br5, we see 5 is penta. So then I'm going to write, again, my prefix plus element with IDE. So this is going to be penta. And then bromine becomes bromide. And then we have HCl. So again, 1 hydrogen. I don't put mono on the first word. So I'm just going to simply write hydrogen. And then Cl, there's 1 of that. We can put mono on the second word though. There's no exceptions to that. We can see mono on the second word in the examples up here. So coming down, we're going to now write monochloride. And we are good with that. Now coming over to, scrolling over a little bit here and doing the formula. This is actually a lot easier in my opinion. Carbon, there's no prefix, so we can just assume 1. tetrahydride, so tetra meaning 4, CH4. Also known as methane, which is the gas that's actually in our gas jets at school. We see nanosulfur, so I'm going to go nana is 9, so S9, dioxide, S2. Oh, I'm sorry, dioxide, O2. Tricarbon, triiodide, that one's kind of weird, so we'll just do tricarbon. And then iodide, I actually put in here because I want you to just recognize iodide is iodine. I know it's kind of a weird one, it's fun to say, but it just becomes I3. Okay, we are good on that. And now for this last one here, we have our hydrogen monochloride, so we actually need to be drawing our Lewis dot structures. And again, covalent Lewis dot structures, just important to remember. Covalent share the electrons, so we're not going to draw arrows, we're not going to draw them transferring, they are being shared. So if I look at hydrogen, for some reason my screen here is not really letting me see in there too well. We'll see how this shows up. So I need to remember my valence electrons. So I look at hydrogen. Hydrogen has 1 valence electron, so I can just draw it like this. Then it says monochloride. So the nice thing is it's already kind of telling me how many there's going to be. I should only need 1 hydrogen, 1 chlorine. Remember, hydrogen's kind of one of those weird ones that can either lose an electron or it can gain. In this case, it's actually just going to share, but you still need to know 1. Chlorine wants to gain 1 electron. If we look at this 7 valence electrons, it's important to remember that every single electron, like you see right here, every single electron is a bond that wants to be made. So with that, what I'm going to do now is I'm just going to draw my bond between these. I'm not going to draw an arrow like I would have done with ionic. Covalent, I'm just going to draw a line between them. Everything is good. That is now a happy bonded covalent because they're sharing those 2 electrons. Those 2 electrons are buddied up. Again, I always tell students, think of it like this single electron turns out got scared and needs a friend now, and so does this single electron, so they're going to partner up just like these ones were already pre-partnered. If we come over to this next one, carbon tetrachloride. So again, right away it tells me what my form is going to be, C and then 4 hydrogen. So I'm going to draw my carbon. I'm going to draw it in the center here. So carbon, and if we look, carbon has 4 valence electrons. So what you'll notice is that all of these electrons on carbon want a partner. They want a buddy because they're all single. So I'm going to start off and I'm going to draw hydrogen. This hydrogen also has 1 valence electron. Oh, guess what? That one's going to partner up there. Carbon's not happy though. Carbon wants more buddies. It wants more hydrogen. So it's going to do that. So it's going to find another hydrogen here. Those ones can partner up. It's going to find another hydrogen. Those ones can partner up. It's going to find another hydrogen. Those ones can partner up. And life is good. Carbon's happy, each of its single electrons found a buddy. Hydrogen's happy because each hydrogen's electron found a buddy. Life is good. Alright, well thank you for following along and listening and learning with me today. As always, if you have any questions, need any extra help, please feel free to reach out and we'll learn together.